The last time we used ORB SLAM and ICP method to create a 3D semantic point cloud from many RGBD images are created from the camera, recent camera when we move the camera around the plants. In this example, we will find the pruning point for prune the leaves. It means we find the pruning points on the petioles. So how can we do that? As you can see here, wait a minute, I will copy a 3D a 3D point cloud, a 3D point cloud, a sweet paper 3D point cloud for us to easy to explain. Okay. Okay, so how can we detect the pruning point? As you can see here, we have petioles here, and the pruning point should be here, and we have to detect a point. We have to define an algorithm to detect the pruning point. And this is how we do that. Firstly, we will separate the petioles, because we have many petioles, and we have to separate them into different point clouds. The algorithm to do that, the way to do that is similar to the way we detect the group of points to detect the center point in our previous example. And then after we separate the petioles into different groups or into different point clouds, we select the middle points. And then if our purpose to is our target, if we want to pruning the lowest petiole, so we can choose the lowest petiole by comparing the middle point according to the y value in the 3D coordinate. And then we will divide each petiole in 5 points, or divide into 5 in each small parts represented by a point. And we will choose a point, one of these 5 points which has the greater distance than 0.02 meter. I mean, if we have divided these petioles in 5, we will choose the if here is 0, 1, 2, 3, 4, 5, we will choose the 2 or 4. It means the second point or the fourth point will be one of close to the stems. We don't know the 0 point will the here or here. It depend on the position of the petiole. If the petioles are in the right hand like this, maybe 0 is here, but if the petiole is on left hand like this, the 0 could be here if we compare by x value. That's why we will choose the fourth point or the second point by the compare the distance to the stem here. The closer will be chosen. That is how we can do. That is the idea. Now is the program. We see on the 3D sweep paper or with lamp cat point. Look at this. This function will help us to find the cut point or pruning point. Firstly, we declare a list petiole. This is the list petiole. Is the separate petiole point cloud, and the list petiole pose is including 5 points of a point cloud, and a point is the center point of that petiole. 5 points of the petiole and the center point. It means we have a 6 point for one petiole. Firstly, we will decrease the number of points in a petiole. After we count this function, the number of points is still greater than 3000. We will decrease it by increase the resolutions until it's smaller than 3000. And next we will separate them and store them in the list petiole. This function is similar, but in this function we also detect the 5 points of per petiole. And then it just decrease the number of leaf and put it in the color point cloud to show the demonstration. They also stamp like that. And next we will find the stamp position according to a petiole. Because, for example, if the petiole is here, the stem point should be here. If the petiole is here, the stem point could be here. It's mean like that. We have to find the stem point to calculate the distance between the second or the fourth point of a petiole to the stem. So how can we do that? We, according to the y values of the center point of a petiole, we will find the point have around that y value of stems, and we calculate the x, y, and z's of that stem point. So here we will find that. Okay, this is the part we will order the petiole point from the lowest to the highest. For us to detect the lowest petioles, also we can find a list of pruning points, and according to the requirement we can pruning one petiole or two petiole or the petiole below a values. It depends on us, but this function will find the list of petiole, and there are orders from smallest to greatest. And this file from is here we find a stamp point. The idea is I already said. And this function we will detect the pruning point. No, this function helps us to calculate the final stamp point, and also detecting that stamp point to the petiole is the close or not. If it's smaller than 0.02 meter, it means this petiole is really close to the stamp, and we should we cannot remove, so we make a mark that petiole is not valid, and we don't do anything to that petiole. And then finally we will find the pruning point. The pruning point when this is valid, it means equal to 1. We will find the pruning point. It is the number. It is the second or the fourth point, depends on the distance between that point to the petiole. That point to the stamp, we find distance the stamp point to that to the second or the fourth point, and then we put into the list. And finally we will colorize that stamp points, petiole points, and pruning points, and then we show it to the point cloud viewer. That's for find the pruning point. In this program, I also write a command service. This command service server is the, if we have a request has value number 1, it means we start to create the 3D point clouds. If we have a request with value number 2, we stop create a point cloud and find the cut point. And later we can add menu command here. And I also write a new the service client. It is the command, sorry, where this, it is the service command here. It has a loop, and each loop we will get in a value from the keyboard, and if we enter the number, if it's a number 5, we quit the program. Number 0, 1, 2, 3, 4, 5, we send that command to the server service. Yeah, command line. Okay, and in this we have used the command line the service. We have to define a service in SRV folder like we did before with RGB image. We have an input and an output is an image, but this command line service we have an input is an integer and output is an integer. Remember, when we build we create a service and with a service message we should build this service message and then we build the program. If not, we cannot include the service.h at the beginning like this. After we build them, we can include them to the program because it will generate a library. Okay. And now we will run a demonstration, and you can read it clearly by download the program from the GitHub. Okay. I also create a launch file for us to easy to con. File no cut point here. This launch file will con the RB slam RGBD node. It's also con the sweet pepper topic RB slam node to create semantic image, and it's called our node too. So firstly I will start them by con the launch file. Oh, sorry, it didn't have a right name. Check again. Sweet pepper. There's the underbar here. I also start the command service. Okay, I will start a this is a point cloud. I will start a backfire because I set it's automatically create a point cloud, so it will start. And now I want to stop and finding the cut point, so I set number 2 here. It will stop and finding the petiole and cut point, and you can see we have 2 petiole, and then in this petiole we had 2 pruning point because these petioles because there is a blank here, so it considers 2 petiole. Because of the depth information is not good, there's a blank here. It divides this petiole into 2, so it's seen that this petiole is a 2 and has one cut point and one cut point here. I think we can select again better. We can change the program to make the make the function find the cut point. Here, find the cut point. We can increase the distance in separate petioles, yeah, to make it becomes 1. Okay, and we increase the lowest. The noise is like the noise value. If the number of points is under 40, it will be removed. And I will build again. I can make. Okay, we will try again. Render roast line rich emit back sweet pepper. I want to change the this text times. Number 2 is stop and find the cut point. So we have one petioles here, and we have a cut point is here. Okay.